Good morning, class. We are looking at section 3, properties of trigonometric functions. The chapter of interest, trigonometric functions. So we covered angles and their measures, trigonometric functions using the unit circle approach. We're going to look at the properties of the trigonometric functions by looking at their domain and range, period of trig functions, signs in different quadrants, find the value of a trig functions using fundamental identities, find the exact value of trigonometric functions of an angle given one of the functions and the quadrant, use even and odd properties. So again, we looked at a ray, a line. When initial side and terminal side come together, it's a complete revolution. In counterclockwise is 360 degrees. The ratio of d to 180 is r to pi. Omega is theta over t, 2 pi times rpm, v is s over t, or r omega, s is r theta, a is 1/2 r squared theta. 1 degree is 60 minutes, 1 minute is 60 seconds. So we have the initial side along the x-axis, terminal side in a counterclockwise rotation. It makes it a positive angle. Negative angle. Standard position along the x-axis is the initial side. So many things that we discussed, straight angle, right angle, you name it. Using the unit circle, first x squared and y squared, they add up to r squared when the center is at 0, 0. Specifically, when we use r equals 1, we get a unit circle. And the definition is such that x comma y, x is represented by cosine, y is represented by sine, and it makes it easy to figure out the quadrantal angles and their values. Tangent is the ratio of sine to cosine of y over x. Cotangent is the reciprocal of that. These two are also reciprocal of sine and cosine, respectively. If, however, we look at the general case where we no longer have the radius 1, but rather radius r, now all of this, they could have had r as this one and this one, r as a denominator, but r was 1, we didn't have to mention it. Now we have to. So sine, which was y, now it's y over r. Remember, over here is really y over 1. Cosine was x over 1. So it's x over r because 1 was the radius. And the rest, as long as we have these two and we know other relationships, for example, tangent is sine over cosine and the rest of them are reciprocals, we can come up with the answer easily. These are some exact values of common arcs, such as pi over 6 or 30 degrees, pi over 4 or 45 degrees, pi over 3 or 60 degrees. We are supposed to be comfortable with those. We are going to look at more properties. So when the function is sine theta, or f of theta equals sine theta, the domain is all real numbers. The range goes from -1 to 1. Cosine works the same way. Tangent is all real numbers. And the domain has this exception that can't be odd integer multiples of pi over 2. Now, they become easier to follow when we look at their graphs in the next section. So for now, the domain for sine and cosine is -1 and 1. Cosecant can be less than -1 or larger than or equal to 1. Secant has the same value. And tangent goes between negative and positive infinity. Cotangent also goes from negative to positive infinity. We are talking about the range. And here's another one. This is the synopsis of everything that is in both. When we go over the graphs, it makes it a lot easier to remember this class. So I wouldn't worry about that at this point. I wouldn't worry about that at this point. I highly recommend you get very comfortable with the graphs and it becomes easy to remember this stuff. All right, what is a periodic function? A function is called periodic if there is a positive number p such that whenever theta is in the domain of f, so is theta plus p. In other words, f of theta plus p and f of theta are identical. If there is a smallest such number, this smallest value, we call it the fundamental period, simply the period of the function of interest. When it comes to sine, it's 2 pi k. We might write 2 pi n in some text. K or n is an integer. We may write, so we can write 2 pi n depending on the text. Or if we go with degrees, we can go with 360 n. In degrees. So if we go a complete revolution, which is 2 pi, for example, then we end up with the same location as far as the terminal side is concerned, and they have the same value as the pi over 3. In this case, this is 7 pi over 3. So the basic idea is to subtract multiples of 2 pi or 360 degrees to come to the first, revolution in essence. When we look at tangent, we remember that the ratio of sine over cosine. In the first quadrant, sine and cosine are positive. In the third one, both are negative, but the ratio is positive. Therefore, tangent of theta and theta plus pi, they give us the same answer, meaning cotangent works the same way. So you want to see that 2 pi is the period or fundamental period for sine, cosine, secant, and cosecant, but for tangent and cotangent is different. It's just pi. So it's pretty straightforward. So a quick recap of a periodic function. For all trigonometric functions, the period is 2 pi except tangent, and with that goes cotangent. So if you're interested in calculating this, you subtract 2 pi and you subtract all the 2 pi's, meaning you subtract multiples of 2 pi, or if it's in degrees, multiples of 360 degrees. So I hope you realize that 17 pi over 4 is 16 pi over 4, which is 4 pi and pi over 4. So the meaning of 4 pi is that we go around for 2 complete revolutions. We end up at pi over 4 in the first quadrant. So this is the same as sine of pi over 4, which is square root of 2 over 2. 5 pi, it's 4 pi plus pi. Therefore, it's the same as cosine of pi. We should know it's -1. So in case of sine and cosine, multiples of 2 pi. In the case of tangent and cotangent, we look at multiples of pi or 180 degrees, and we know 5 pi over 4 is pi and pi over 4. Therefore, we are just concerned with pi over 4. So it's equal to tan of pi over 4, and tangent of pi over 4 is 1. Again, a quick recap. For sine and cosine, subtract multiples of 2 pi. If it happened to be negative, by the way, you can add multiples of 2 pi. It works the same way. In the case of a tangent or cotangent, then you deal with pi. And remember, 2 pi, the same as 360 degrees, pi the same as 180 degrees if it's given in degrees. Determine the sign of a trig function in a quadrant. Well, it should be pretty obvious. First and foremost, we remind everybody that x squared plus y squared equals 1, and p is x comma y cosine comma sine. So in the first quadrant, everything is positive, meaning x is positive, so cosine is positive, y is positive, meaning sine is positive. And the rest of them, you just follow x and y. So, for example, if we are in a quadrant that sine theta is negative and cosine is a positive, we should be able to figure out where we are. So when you look at cosine here, so let's just put cosine positive, sine positive in the first quadrant. And cosine means x, sine means y. So if you go to the second quadrant, cosine is x becomes negative, but sine remains positive. In this case, cosine and sine, both of them are negative because in the third quadrant, x and y are negative. In the fourth quadrant, x is positive, cosine is positive, y or sine is negative. So when this is the case, you can even go with the ratios, even without figuring out the quadrant, you can figure out that in this case, everything. See, since they have different signs, everything becomes negative except cosine is positive, so is secant, because secant is 1 over cosine. So sine and cosine have different signs, even if you don't figure out which quadrant. We're going to discuss the quadrant. Cosecant is the reciprocal of that is negative. Tangent is the ratio of these two, becomes negative. Cotangent is the reciprocal of that is negative. Everything, because sine is negative, everything becomes negative. Because cosine is positive, secant becomes positive. And so this one puts us in the fourth quadrant. So tangent is y over x, negative. Cosecant, 1 over y, negative. Secant is 1 over x because cosine is positive. So it's reciprocal, which is 1 over x. Cotangent is the reciprocal of this, x over y. This is negative, so is this. And so we have this concept. They're all positive here. Sign is positive. And when sign is positive, by the way, with the sign goes cosecant. Everything else is negative. Over here, the only thing positive is tangent. With that goes cotangent. Everything else is negative. Over here, cosine is positive. With cosine goes secant. So is secant, but everything else is negative. So that's how you look at. Just look at sine and cosine, and you can figure out the rest of it. So stick with sine and cosine. And again, it is explained here, but I highly recommend you just stick with sine and cosine, and everything else you can easily make a decision. Here's a simple example. We know sine is positive. We know cosine is negative. And we want to come up with the quadrant. So sine is positive in the first and second quadrant. Cosine is negative in the second or third quadrant. So what's in common? This is how you figure it out. It's quadrant 2, therefore. So I hope everybody is clear how we arrive at the answer. It's pretty simple. All right, let's look at what we call fundamental identities. First, x squared and y squared, they add up to 1. Therefore, cosine squared plus sine squared, they add up to 1, or sine squared plus cosine squared. It doesn't matter in what order. So sine squared and cosine squared, they add up to 1. Let's divide both sides by sine squared once to figure out what's going on. Let's divide both sides by cosine squared to figure out what's going on. We're going to do both of them because we want to create more identities. When we divide by cosine squared, we know sine over cosine is tangent. So this is tan squared. This is plus 1. We know 1 over cosine is secant, so this is secant squared. So from this one, we proved this one. And this comes from x squared plus y squared equals 1. This time, let's divide by sine squared, everything. So now this becomes 1. Cosine over sine is cotangent, so cotangent squared. And 1 over sine is cosecant, so cosecant squared. And now from here, we proved 2 more identities. These are known as Pythagorean identities. So this bottom are called Pythagorean identities. And so here's the name. These are quotient as far as terminology is concerned. All of them are considered fundamental identities. Quotient identities, tangent is sine over cosine, cotangent is cosine over sine. Reciprocal identities, cosecant is 1 over sine, which obviously means sine is also 1 over cosecant. Secant is 1 over cosine, cotangent is 1 over tangent. And these 3, sine squared plus cosine squared equals 1, tan squared plus 1 is secant squared, cotangent squared plus 1 is cosecant squared. They are called Pythagorean identities. Pythagorean identities. We want to find the values of a trig functions using fundamental identities. And these are some of them: quotient and reciprocal identities, and I hope you remember the Pythagorean identities as well. We're going to use those for this one. Sine is given as square root of 10 over 10, and cosine is given as 3 square root of 10 over 10. So first and foremost, we can find the tangent, which is sine over cosine. So sine is given, cosine is given. We find the tangent, which is sine over cosine. So we're going to divide square root of 10 over 10 by 3 square root of 10 over 10. And I hope you realize the complex fraction 10 drops. Believe it or not, square root of 10 drops, and you end up with 1/3. I hope nobody has any problem. Then let me rewrite that. It may be easier to see it this way. If you see that the numerator is square root of 10 over 10, and this is 3 square root of 10 over 10. So you multiply these two, the extremes, you put it at top. You multiply the means, 3 square root of 10 times 10. And you see that everything drops except 1/3. So this becomes 1/3. Again, I'm just reminding you of how you do complex fractions. I hope nobody has any problem with that. All right. Now, reciprocal of this is cosecant. Reciprocal of this is secant. Reciprocal of this is cotangent. So let's do this pretty fast. Cosecant is 1 over sine, so 1 over this. And again, 10 comes at top, and it becomes square root. Cosine is the reciprocal of this number. So this number 10 comes at top. By the way, the ratio of this ratio is this. This ratio is the same thing, so it's square root of 10 over 3. And cotangent is the reciprocal of 1/3 or 3. So it's very straightforward. So if you are solving this and sine and cosine are given, immediately find tangent and the rest of them, just the reciprocal, and you're done. It goes extremely fast. All right. We want to find exact values using identities, and you see that it's being squared, so perhaps we have to use the Pythagorean identities. That's why I wrote them for you here, so you have them handy. All right, and of course we need to know others, like the reciprocals and so forth. For example, we know 1 over cosecant is sine, so this is sine squared. We know sine squared plus cosine squared equals 1. So I hope you see the importance of knowing your identities. The ratio of cosine to sine is cotangent. So this is cotangent of pi over 3. And you just write this, they cancel each other. So we are using identities. All right, so let's see. The ratio of sine to cosine is tangent. Again, they cancel each other. We get 0. Secant and cosine are reciprocals. So 1 over cosine is secant, 1 over secant is cosine. So this is cosine, and because this is squared, this is cosine squared. And sine squared plus cosine squared equals 1. Sine squared plus cosine squared equals 1. Finding the values of the trig functions of theta when the value of one function is known and the quadrant is given. We can use two different methods. One of them, we use the circle of radius r. We draw a circle, x, y, or we come up with that using the square root of x squared plus y squared. So x, y, and r. And of course, we are paying attention to the quadrant. Therefore, we know x is positive or negative, y is positive or negative. And so when we know the location of this point, we can come up with the answer through all the values. However, the second method is, as always, using identities. So here's a simple example. We're going to do both methods just for the sake of argument. And generally speaking, as long as you can do one, that's good enough. You don't have to do both as far as I'm concerned. But you really want to be familiar with both methods. So sine is given. First and foremost, I want to remind you of all of this. Second, sine is positive. So right here, if we stop, that means the first or the second quadrant. This means first or second. Cosine is negative. That means the second or third quadrants, putting them together, quadrant 2. So we already know it's in quadrant 2. Since sine is 2 over 5, and if we want to go with y over r, that means we can assume y is 2, r is 5, and we can find x. Now remember, sine is the same as, in essence, the y coordinate, and in the second quadrant, it is x that is negative. So we have to figure out the x, and we have to pay attention to the quadrant and give them the proper signage. So this is the location. We don't know the x, we know the y, we know the r. So we find the x using x squared plus y squared equals r squared. And remember, y is 2. So 2 squared is 4. 25 minus 4 is 21. Plus minus square root of 21. However, we know it's in the second quadrant. We choose the negative one. So we do the choosing according to the quadrant. Practically, we are done. We have x, we have y, we have r. We have all of them. So just plug in. So we have sine. Cosine is x over r. Tangent is y over x. So let's do that. Cosine is x over r. Tangent is y over x. And you can go with the rest of them or just write the reciprocal. For example, the reciprocal of sine gives you cosecant. The reciprocal of cosine gives you secant. The reciprocal of tangent gives you cotangent. So you can use the identities here. So cosecant is 5/2. Secant is r over x, or as I said, the reciprocal of right here. And is cotangent, the reciprocal of tangent. When you do that, in essence, you're mixing the identities with that, and that's fine. The fact of the matter is the main part, which was figuring out x, y, r, is done through this method. If they ask us, this is the meaning of it, using circles, you got to be able to tell what is x, what is y, what is r. Okay. Now, if we want to do the same thing, but this time we want to use the identities. First of all, Pythagorean identities, reciprocal identities, quotient identities, whatever you want to call them. Those are, in general, fundamental identities class. And so, because sine is given, and we look at the first one, sine squared plus cosine squared equals 1, we can find cosine, and a cosine is negative. We make that negative. We already have the quadrant. We've looked at it, and we know it's in quadrant. So sine squared and cosine squared, they add up to 1. Replace the sine with 2/5. When you square this, you get 4/25. So cosine squared is 1 minus 4/25, or 21/25. I'm assuming nobody has any problem with these calculations. This is 4/25. So cosine is plus minus the square root of this number. And 25 comes out as 5. Now we go back, we know cosine is negative, so we choose the negative one, and that is obviously the same quadrant we found in the previous step, which is quadrant 2. We already know that. And so since we have sine and cosine, then we go here. Tangent is sine over cosine. The rest of them just reciprocal. The reciprocal of this is 5/2. The reciprocal of this, the reciprocal of that. You find the reciprocals, and this becomes cosecant, this becomes secant, this becomes cotangent. If you find the, so first with the cotangent, 1 over this. I hope you see that you put the 21 at top. I want to show you in case. So you put minus 21 over 2 square root of 21. And when you do that, the product of these two is 21. That's how you arrive at this answer. So I want to make sure that you can handle the algebra behind it. It's really simple. So cotangent is the reciprocal of tangent. Cosecant is 1 over sine. So 2/5 becomes 5/2. And secant is 1 over cosine. So number 5 comes at top. And now this one, you basically multiply by square root of 21 over square root of 21 to rationalize it. We're going to get a couple more examples like this, but we're going to go through it fairly fast. It really repeats the same process. You can go either by x, y, r, the circle of radius r, or you can go by fundamental identities. All right, again, let's use the circles. In this case, cotangent is given as 1 over 3, and cotangent is x over y, and sine is negative. So As far as the quadrant is concerned, cotangent is positive in the first and third quadrant. So which one of those sign is negative? It's the third quadrant. So again, this is positive in the first, positive in the first and second quadrant. But sign is negative in this. My apologies, third. I said third and I didn't. In the third quadrant. So in the third quadrant, sign is negative and therefore it belongs to the third quadrant. In the third quadrant, x is negative, so is y. Therefore, this is the third quadrant. In the third quadrant, x is negative, so is y. So the values are -1 and -3. Now, x squared plus y squared is r squared. That means 1 and 9 is 10. And r is square root of 10. R is square root of 10. So now we just plug in tangent is y over x, or the reciprocal, if you will. Sine y over r. Again, going through this pretty fast, but I hope you realize when you are asked to solve a case like that, you must come up with the quadrant. You must come up with the values for x, y, r. When we have those, the rest becomes a piece of cake. So tangent, y over x, sine, y over r, cosecant, r over y. Right away, we use that, r over y, the reciprocal. I'm going to assume everybody can do the math. It's pretty simple algebra. Cosine is x over r. And we go through the process. And now secant is r over x, or the reciprocal. Now, what if we wanted to do this one using identities? Again, we already know the quadrant. And since one of them is given cotangent theta, we are going to use this is a quadrant 3. We already know that. We're going to use one of those Pythagorean identities, because cotangent squared plus 1, or 1 plus cotangent squared, is cosecant squared. We know that, and therefore we can get to cosecant. So replace the cotangent with 1/3 and square it. You get 1 over 9 here. So 1 over 9 plus 1 is 10 over 9. So cosecant is plus minus the square root of this number, and 9 comes out as 3. Now cosecant is the reciprocal of sine, because sine is positive, so it's cosecant, or you can say because we are in the third quadrant. Either way, you have to come up with the proper signage. You first write plus minus, then you make a decision according to the quadrant. So we have cotangent, we have cosecant. That means we have 2 more, the reciprocals, okay? So for example, sine is the reciprocal of this, and tangent is the reciprocal of that. Those are the fastest one. Let's do that. So sine is the reciprocal of this number. So 3 comes up And then if you multiply by square root of 10 over square root of 10, I can quickly show you. So right here, you can multiply by the square root of 10 over square root of 10. And that's your sine. As far as tangent is the reciprocal of 1/3, which is 3. Now, what is the best course of action to find others? So we want to get to cosine. We're going to use one of those fundamental identities. We know tangent is sine over cosine. We have sine, we have tangent, cosine is missing. Now, we can continue working on it, or I hope you realize you can see that cosine is there for sine over tangent. So I hope you see that from here, you can go here. That's the same in essence. One easy way, you can interchange these two. If we had a number here, and by the way, if we had anything here, over here we have like a fraction bar and 1. You can think of this as a fraction bar and 1. And this is really the cross product. And what you can do, whatever you have here, you can also interchange because the cross product remains unchanged. So write sine theta minus 3 square root of 10 over tan theta, which is 3. And obviously, this 3 cancels out this one, minus square root of 10 over 10 is cosine. And secant is the reciprocal of this. And the reciprocal of that is minus square root of 10. It's pretty simple. All right, so we can use the circle and find x, y, and r. We can find the identities in both cases. The most important thing is to recognize the quadrant. If we don't recognize the quadrant, it doesn't work. All right, we want to use even and odd function. So in general class, all trigonometric functions are odd, except these two. Cosine of negative theta is cosine theta, secant of negative theta is secant theta. First, let me just remind you of even and odd functions from algebra. Here's the definition you probably remember. Even means f of minus x equals f of x. So if you change x to minus x, it makes no difference. That means symmetric with respect to the y-axis. Odd, f of minus x is minus f of x. That means symmetric with respect to the origin. So when we know this definition, px comma y, px comma minus y, when we have theta versus negative theta, the x value remains the same, and x corresponds to cosine. Therefore, cosine doesn't change. Cosine is positive here in the first quadrant and in the fourth quadrant. And in the fourth quadrant, we are dealing with minus x or minus theta. Because cosine is positive, so is secant, because secant is the reciprocal of that. So, to answer these examples, cosine of negative 60 is cosine of 60, and cosine of 60 we should know is 1/2. Sine of negative, anytime you have a negative angle, make sure you bring it out. In this case, when we bring it out, nothing happens because it's an even function. In this one, bring the negative out. And now 390 degrees is larger than 360 degrees. And So you just write 360 plus some number, 360 plus 30. So this is a complete revolution. You can ignore it. So it's minus sine 30 or negative 1/2. It's a complete revolution. Remember that. Over here, again, first take care of the negative sign. Remember, everything is odd with the exception of cosine. So this is odd, meaning negative comes out. And not only negative comes out, this 37, so maybe I write this first. So I write cos negative tan of 37 pi over 4. Now 37 pi over 4 is larger than 2 pi. So you take out multiples of 2 pi and you notice 36 pi over 4 is multiples of pi. My apologies. You want to take out multiples of pi because tangent is a periodic function with the period pi. So the period for tangent is pi. For sine and cosine, the period is 2 pi or 360 degrees. So you take out 9 pi and nothing happens. And this is negative tangent pi over 4. You know tangent of pi over 4 is 1 with the negative in front of it becomes negative. A quick recap, cosine is an even function, so it's cosine of 60. Sine is an odd function, so it's minus. And same thing with tangent becomes minus because they're both odd. And of course, multiples of their period, in this case, 2 pi or 360 degrees, in this case, 2 pi or 360 degrees, in this case, pi or 180 degrees. So using that concept, we want to find the value of this expression by looking at this part. Since the period is pi, we add or subtract makes no difference. This is the same as cotangent of theta. Same thing here. 2 pi or 10 pi or pi add or subtract makes no difference. Cotangent of theta, and therefore you have how many of them? 3 of them. So 3 cotangent theta, 3 times negative 2 is negative 6. So that's how you simplify this. Here's an interesting question. We want to find the sum of sine of 1, sine of 2, all the way to sine of 359. Okay, so in order to see how that thing is going to work, by the way, if we do the drawing sometimes helps, okay? So if you pick up one number and for example, let's assume this is 20 degrees, okay? And then we have here minus 20 degrees, just for the sake of argument. I don't want to pick one. It's hard to, do the drawing. Assuming this is 20 degrees and this is minus 20 degrees, they have the same y, but they are opposite. They cancel each other. So that's the concept we are going to use here. So, for example, just so you know, sine of 359, that you go all the way. Remember, this is 360, so right before that. So sine of 359 is the same as sine of -1 degrees. Sine of 358, go all the way to 358. It's the same as sine of -2 degrees. That's the concept we are going to use. So let's do that. So we write those. 359 means -1 degree. 358 -2, 353 -3, so on and so forth. So now we know that sine is an odd function. So sine of -1 is minus sine 1. Sine of -2 minus sine 2. Sine of -3 minus sine 3, so on and so forth. But also I want to write the middle part so you see what is left. So take a look. I want to make sure we understand this. So this part is the positive side. This part is a negative side, which is the same as this, right? But what is in the middle, we're going to continue all the way to 179, and then all the way to 180. And then this is 181. Let me just write that at top of it. This one is plus sine of 181 degrees, which is the same as sine of -179 or minus sine of 179. What does it show? Everything cancels out except sine of 180. Sine of 180 happened to become 0. I hope that was interesting. And you see how we arrive at the answer. If we do the same thing to cosine, class, the same thing happens. We write exactly the same as the previous one. And we come up with a cosine of 180. Okay, so we are adding in this fashion. So we are repeating the same concept. Since this is an even function, so it doesn't matter it's negative or not. So we can get rid of the negative. And so we have 2 of this. We have 2 of this. We have 2 of this. And so what we can do, we can write them in the following manner. We have, so let me just put them together maybe. So we have 2 of these, 2 of these, 2 of this. So what happens? We write 2 cosine 1, 2 cosine 2, 2 cosine 3, all the way to what number? 2 cosine of 179 and 1 cosine of 180, because 180 right smack in between, we don't have 2 of them. Okay. Let's see if I can. This one is pi over 180. So that one is 1 of it. And so cosine of 178, this is 180 minus 2, just for the sake of argument. So you see 178 is located somewhere here. Let's assume this is to scale. This would be 178. And why are we writing this? Because I want you to notice that in the first quadrant, like those stuff, for example, are positive. In the second quadrant, like those stuff are negative. So they cancel each other. So we are going to write this as 180 minus 2, 180 minus 1, so on and so forth. So it's important to know this cancels out this one. This cancels out this one. Everything cancels out except cosine of 180. Cosine of 180 is negative 1. So this is a trick that you use for this question. I want to look at the last one. From a parking lot, you want to walk to a house on the ocean. The house is located 1,500 feet down a paved path that parallels the ocean, which is 500 feet wide. So this is 1,500, 1,500, this is 500. Along the path, you can walk 300 feet per minute, but in the sand on the beach, you can only walk 100 feet per minute. So we can go faster here, 300 feet per minute here, 100 feet per minute here. And here's the illustration. The time t to get from the parking lot to the beach house can be expressed as a function of angle theta, this angle, shown in the illustration. Calculate the time if you walk directly from the parking lot to the house. And so we have this formula. The time it takes is 5 minus 5 over 3 tan theta plus 5 over sine theta. They have given us this one, where theta is obviously in the first quadrant between 0 and pi over 2. So we want to look at this and find the values that we are looking for. First and foremost, to make some sense out of this, let's do the drawing like this. This is theta. Okay, this is theta. Okay, class. And by the way, it depends how much we walk here and then when we go straight. We can go all the way here and then go up, or at some, or go strictly from the sand. It makes no sense because we are going slow, or some here, some here. That's why they have that. So with that being the case, and they calculated and they want to see how long it takes, they want to maximize, minimize. It's a concept of optimization. And so if this is 500, this is 1,500, number one, tangent is 500 over 1,500. And also we can find the hypotenuse by squaring this, and taking the square root, or we can look at the ratio, which is easier. So first and foremost, what is the tangent? The opposite. Just write that. So this is the opposite. This is the adjacent. And 1,500 over 500 over 1,500 is 1/3. If you want to go with the circle that we found, we're going to go with y and x in essence. Okay, we can go with y and x in essence. And so with that being the case, we can find this hypotenuse by squaring this one, adding them up and taking a root. But since the numbers are huge, let's stick with easy numbers. Let's go with r squared equals x squared plus y squared and find r to be square root of 10. And so let's assume this is 1, this is 3, this is square root of 10, just because it makes calculation easier, not that you have to. It makes easier and smaller numbers. So when we go to this formula, we have tangent theta, 1/3. What is sine theta? Sine theta is the opposite over the hypotenuse. So 1 over square root of 10. So we are going to use this formula and we are going to plug in and we are done. We just have to do the arithmetic. This is 1. This is 5 square root of 10. So the answer is precisely 5 square root of 10. And we can approximate it to 15.8. This was the time in minutes. T is the time in minutes.